Hey everybody, Lonnie here. Thanks again for watching my videos. Today I'm going to be talking about bulk queries, how to optimize reading data from Pi. I hope that you guys are having a great day. I know that that I am, although it is a little bit warm here today, so I'm just kind of staying inside where it's cool. I did do a little work on my bathroom remodel this morning, and I don't know if you've ever done remodeling work before, but the one thing that I realize is that it's a lot of hard work. Coding, on the other hand, for me, is not nearly as difficult physically. Obviously, mentally, it can be challenging. And anyway, I'm thankful that I write software for a living and I don't do home remodels for a living, because there's a big difference. I do enjoy the home remodel, but you know, I'm not nearly as proficient at it, and everything seems to take a lot longer. Anyway, enough about that. We're going to go ahead and talk about how can we improve the performance of applications that we're writing when we're getting data out of Pi. If you're using the SDK and you're using Git values and you're pulling snapshot values, or you're pulling time series data out, some of the previous videos that I had show you how to do, you're likely not doing it in an optimal way. And I've written plenty of code that is not optimized. I've seen plenty of code that is not optimized. So what I want to show today is how you can improve your speed of reading data out of Pi drastically. And this is something that you should be doing. Why, you ask, should you be doing this, Lonnie? I go, well, normally this data is going somewhere, and I'm guessing 9 out of 10 times it's going to be consumed by a person. And if you do the work that I do, where you're sending data to a website or some kind of application, it needs to get that data as quick as possible. We want to you know, get the data in front of the user, and if you're not doing it in an optimal way, you'll just see that hourglass. You're waiting for the data to load, and if your users are anything like the users I work with, and myself included, I like stuff to be very fast and come up. I don't like to wait very long at all. So we need to figure out strategies on how to get this data out of the Pi system faster, and get it in front of the user as quick as possible. So this is one strategy. This is probably like where you should start, I would say, is just make sure that the queries, the raw queries that you're using, are written as optimally as you can write them with the tools that you're provided. That generally goes for any time you're querying a database or a data source. Think about speed. Think about you know, if it is slow, look into why it is slow and see if you can speed it up. So anyway, we're going to go ahead and dive into it. So I hope this will show you something that you will be able to use in your next project, maybe. Okay, so let's go ahead and get to it. Okay, this is my test application. This is the same application that I've used in my other examples with event frames. We're just connecting to my Pi system. There's a class that I have in here called connection info. If you go into that class, you can change your username, password, server name, database name, and that'll set up the connection to your Pi system. I won't dive into any more explanation on this. You can see the previous videos to get more detail on how that works. So what we want to do is we want to pull in some elements and do searches off of those elements, and then we want to look at the attribute values. I want to get snapshot values for all the attributes for all the elements that I'm going to pull in. So let's take a look at our Pi system real quick, just to see what we're going to query here. This is my Starfleet AF structure that I'm starting to build out, and in that I have a template called an antimatter relay, and under that, under these relays, I've created 50 antimatter relays. And if I come over and look at one of these, we can see that this is the template name here, and we have attributes, various attributes, 8 altogether, that are showing different different values associated with each antimatter relay. So what I'd like to do is set up a search using the same type of searches that we're using for event frames in my previous videos that I just did. This time we want to use that for element searches, which I did mention at the end of my last video, so this is an example of that. Just to get familiar with how the search is going to work, we can come down here to this element search and we can create a new search, and we can just pick out the things that we would like to search off of. And here I'm going to search off of the template antimatter relay, and I'll do a search, and you can see it found 50 elements here, and that really is all I want to do for my element search. So let's copy this string here, and we'll use that when we start setting it up, setting things up in our application. All right. So let's go ahead and this will be our element search. Element. And we want to set up a query, and that's just going to be equal to the string that we just copied in. I need to change these double quotes to single quotes. And once that query is set up, we want to use the AFElementSearch class to perform our to set up our search that we're going to execute off of. So we'll go ahead and call this our search, and we want to create a new AF element. And this is not recognized right now, and the reason it's not is because we don't have the proper using framework in here, and this is under the OSIsoft AF search namespace, and so we want to bring that in, and then we'll be able to get our IntelliSense and everything working. So this is going to require us to send in our database, which is our AF database, and a name for the search, which you can call it anything. I'll just call this relay. Let's call this our relay search. And the last thing is we just want to send in, we want to send it that string. Okay, once we have our AF element search kind of configured and ready to go, we need to actually set up our we need to call find elements to get the values and be able to iterate over them and bring them in. So this is very much how we're doing it with event frames. So we can come into here and we make our let's go ahead and do results, and that's going to equal our search, and we want to do find elements. And here the same thing, we have the start index, this full load, and this page size. The start index, I want to start at 0. I want to start at the first element that we find. I'm not going to page through it. And then let's go ahead and do a full load to bring in all the things with elements. This may or may not be something that you absolutely need to do, but just to be safe, we'll go ahead and bring in a full load to make sure that we have everything and we don't incur additional calls back to the Pi system that would result in slower performance. So we're just gonna we're gonna get these elements all at once, and we have 50 elements. So let's go ahead and bump this up to say, hey, give us at least 1,000 elements off of that search, just to be safe, well above the 50 that we know that we're going to pull in. This would be some number that I'd want to set to make sure that I get all the elements that I'm looking for in that search. If you have a lot of elements, then there's limits to what you want to do here. But for this example, this will work for us. Okay, now that we have our results, all we need to do is iterate through them. And here we can do a console write line. I'm going to do CW for a shortcut for console write line, and we'll go ahead and we'll just let's just display the element name. Yeah, our element name, and let's try running this and see how it works. Okay, we connected, and we can see that we pulled in all 50 elements. So that's great. First step. Now the next thing we want to do is we want to we want to bring in our values. We want to read all those attributes. So in order to do this, we need to go through each element, and we need to look at each value, each attribute, and we want to call get value off of that attribute. So I'll show you how we're going to do that, but just keep in mind what we're doing here. We're going to iterate through 50 elements like we're doing now, and then each one of those elements we're going to make 8 get value requests. And what is happening on the with the SDK, in the AF SDK and the server side, is these requests are basically getting executed individually. They're not getting executed in bulk, and we really this can be very costly and take a lot of time. If you think 50 times 8, that's 400 values. If you had you know, maybe you had another few hundred, you could easily start running into making thousands of calls, and this is something that I've seen in real code, and it's not pretty. So let's go ahead and do it the wrong way first, and then we'll do it the optimized way second. All right, so we're going to iterate through each attribute associated with the element inside this loop. So we'll do another for each, and here we want to just come through and iterate through our attributes and get the snapshot value. So let's go ahead and grab that. Get value will pull that in, and then we can go ahead and print that out to our screen. Put in the attribute name and followed by its value. This is actually snapshot. Snapshot, if we hover over snapshot, we can see its type AF value. So that's going to have the value, the unit of measures, and other various items. But we're interested in the value here, and we're going to convert it to a string and just display that. And the other thing too, let's go ahead and throw in our unit of measure, just for fun, so we can see that. And we'll go ahead and close this out. And why we're not liking this? Because we have an extra parenthesis in here. Okay, let's go ahead and run this and just see what happens. Now remember, we're going in and we're making a bunch of calls here. We're essentially making 400 calls to get all these values. So you see a lot of stuff came in. We have our values here, and you know, we brought everything in. So let's go ahead and see how long that actually took us. In order to monitor the length and the activity that's happening over the network, I want to use an application called Wireshark. You can find Wireshark on go to their website, just Google Wireshark, and you can get download it and install it on your computer. Essentially this is monitoring all the network traffic that's happening through any kind of network card or other thing that's on my system. So I can go down. It's kind of a low-level monitoring tool. I want to take a look at my Wi-Fi connection here, because that's where everything's getting sent out. Obviously, it has to go out to my server that's setting up in the cloud. And so I'll go ahead and take a look at that. You can see we have a bunch of traffic coming in. This is just a bunch of random stuff. I really don't want to see all that stuff. What I want to see is just my just the things that are going over the port 5457, which is what the AF SDK uses to communicate to AF on my server. So my server has port 5457 opened up, and it's accepting a request and it's sending data back and forth. So anytime I'm looking at the destination 5457, or if something's coming and the source is 5457, it's coming back to me, I want to look at those two items. So I'm on my Wi-Fi network, and I have these two options set up, and we'll go ahead and start that. And now you can see there's nothing, there's obviously network traffic that's happening right now, but we're not seeing any of that because this is just looking at the information that's associated with my request to the Pi system. So we'll execute this, and we can see what happens with our with Wireshark and see what it picks up. Okay, you can see a bunch of stuff happening, a lot of requests back and forth, and you can see these requests are going on while it's scrolling, so there's additional requests that are happening as I'm calling that get values. Altogether, there were 360 packets that were sent, and that took 8.68 seconds. So I'm going to go ahead and turn off this read key because I want to just make sure that we're only looking at we're not including that time, because you see another came in here, 24.3 seconds, and I just want to make sure that we're in fact getting good results. Actually, let me close this out. I'm going to Control R here to reset my Wireshark and just get a new capture going on. Once again, as the data is flowing in, you can see we're getting requests and data flowing back and forth. So 8.66, that seems to be about where we are. So now let's go ahead and try to do this a better way and see if we can improve that. Okay, so what we want to do next is we want to do a bulk call, and a bulk query or a bulk call is just going to make this this call to get all these attribute values. We want to do it in one call, and we want to get all that data back from that one call. We don't want to just keep making calls back and forth and not give the Pi system an opportunity to be to execute all that in one fell swoop. So we're going to use a class called AFAttributeList, and AFAttributeList is just going to get a list of all the attributes that we want to get values for, and we're going to build that list, and then we're just going to make one call after we build that list. So let's go ahead and give that a shot. So we still need to find our elements, and we still need to iterate through our elements to set up this our attribute list. So first, let's go ahead and create an attribute list that we can utilize. And we don't have, we're not getting IntelliSense here because once again the namespace that we need to use is not, I'm hitting Control period, and that'll bring up, we need to use osisoft.af.asset, and that adds that up here as a using statement, so now we have access, and our attribute list is set up here. So what we want to do is just populate that list with all our attributes. So here we're iterating through our attributes. We're not going to call our snapshot values here anymore, but all we want to do is just we just want to build that list. So let's go ahead and take our attribute list, and just very simply we're just going to add in our attribute. Once we have that, we're set up to where we can make this single request and get all the values. So let's say this is, whoops, let me put some notes here just so that we know this is not optimized. And this is optimized. That down here. Okay. Now we're going to just make one call to get all the values. And Similar to how we just did it with a single attribute, now we're just calling get value off of that attribute list. That'll now go out and get all the values for all the attributes. Now let's go ahead and just iterate through to see that data, just to make sure that we're doing we're kind of keeping apples to apples comparison here. So we want to go ahead and let's pull in our snapshot. Yeah, let's do that. Snapshot in our snapshots. Okay, let's do a console write line and bring in and display this data. So one of the things is we need to we don't necessarily know what element we're working on, so we need to display the element name. So let's go ahead and say element and element, and we'll put in, we're going to look at our snapshot, and we want to look at the attribute associated with that snapshot, because remember, snapshot is actually a list of AF values, so we're type AF value. So we're looking at the attribute, and then off of that we want to go ahead and find the element, and then we want to display the name. So we're kind of working backwards. And then let's go ahead and do the same thing and display the attribute name. Finally, let's go ahead and make sure to display the value here. And snapshot, same thing, value and toString. And let's go ahead and do the unit of measure. Also, snapshot, unit of measure. And do our closing quotes. Let's fire up Wireshark here. Let's go ahead here. Okay. And let's try running it. So that was a lot faster. The data came through very quickly there. Could hardly even see it. And you can see it here. After it displayed all the elements, you can see here we're down to 5 seconds instead of that 8.6 seconds. Okay, let's do that one more time just to see what happened. And here you can see we're connected to the Pi system. We're going to see all those elements come in. There's elements. Now we're making that bulk call. Nothing's happening, and then that data came in at the last second. You can see how quickly that data came in once the call was executed on the server. And you can see here we're right about 5 seconds. So we went from 8.6 seconds to 5 seconds. So that's a significant increase. Okay, I want to calculate that. We did we had 8.6 seconds. And now we have, so 8.6 minus 5, that's 3.6 seconds divided by 8.6. That's a 41% increase in speed in doing that query. So the point here is do things in bulk if you have the ability to do them. If you're looking at attributes, values, snapshot values, then set up that attribute list, put everything in there, and then you can call the get value to get the snapshot value. Now the cool thing is that attribute list, it also works with things like trends. So if you want to get interpolated values or plot values or recorded values, it's the same way. You just make a different call with that attribute list. Instead of calling get value, you call get values, and you can set up the calls just like you would with a single call for a single attribute. Now the downside here, there is a little bit of a problem, and the problem is that we have this big attribute list, but we don't necessarily have that organized by elements anymore, where before we could iterate through an element and we could look at the attribute values. Now all we have is we just have this giant list of attributes, and they're not sorted by element or anything like that. So that it will require a little bit of extra coding to, depending on what you're trying to do. If you may have to do some kind of filtering and grouping them back by element, which really isn't all that difficult. There's a lot of different ways I could think about going about it, but it is something that an extra step that you have to do to kind of maybe reorganize that those values in a way that's a little more useful when you're trying to process it and do stuff with it. So that is the end of this video, and I hope that you use this attribute list and these bulk queries to make optimize calls in the future. This code will be on GitHub, so make sure you can see that in the show notes and you can use that freely. And my name is Lonnie. I hope that you're finding these videos useful. Please press the like button and subscribe to my channel if so. And if you have any ideas or suggestions or would like to see certain things that you're kind of wondering how to do or you're struggling over, post it in the comments and I'll try to get to it if I can. Coming up, I want to do, I'm working on a series right now that will use Angular. There's been a lot of requests for Angular, the new Angular 6 now, setting up an application, an Angular 6 application that queries data from the Pi system and then brings that in and displays it, similar to what I did with the Angular JS video, but updating that. So I'll be working on that. Look for that to be out soon. And until next time, take care. Keep working on it. This is good stuff. These are great skills, and I'm really really happy that you're watching this video and you're working on your skills. Super important. So we'll talk to you later.